All right, today we are getting the straight story on light. We're going to talk about how it travels, what happens when something blocks its path, and how that one simple idea can explain some of the most amazing sights in our entire universe.
I mean, really think about it for a second. You walk down the street on a sunny day, and there it is, this dark twin, stretching and shrinking, following you absolutely everywhere. Why? What's actually going on there?
You know, believe it or not, the reason you have a shadow is the exact same reason we have these huge, spectacular events in space. It's all connected by one single fundamental rule of physics.
So, what is this powerful rule? Well, let's break it down.
Okay, it's got a pretty fancy name, the rectilinear propagation of light. But really, all that means is that light travels in straight lines. That's it. It doesn't curve, it doesn't bend. It just shoots straight out from its source, like the sun or a lamp, until it hits something. And check this out. This is a super simple way you can prove it yourself. If you line up 3 pieces of cardboard, each with a little hole in the middle, you can only see the candle on the other side if those holes are in a perfect straight line. If you move just one of them, even a tiny bit, poof, the light's blocked. It won't bend around the corner to find your eye. So that little experiment leads us to a pretty logical next question, right? We know light travels straight, so what happens when its path gets blocked? Well, it really depends on what's in the way. Some things, like glass or water, are transparent. Light goes right through. Then you have translucent stuff, like wax paper, which lets some light through but kind of scrambles it up. And then you have opaque objects, things like wood, metal, you, me. They don't let any light pass through at all. And that is where things start to get shady. So let's take a closer look at exactly how these opaque objects create the shadows we see every day. Turns out you only need 3 ingredients to make a shadow. First, you need a light source, say the sun. Second, you need an opaque object to get in the way, like a person. And third, you need a screen, which is just a fancy word for whatever the shadow falls on, like the sidewalk or a wall. Now, here's where it gets interesting. Not all parts of a shadow are the same. The really dark, crisp part right in the middle, that's called the umbra. This is the spot where the object is blocking all of the direct light from the source. It's a zone of total shadow. But then, around that dark center, you usually see a sort of fuzzy, lighter edge. That part is the penumbra. It's an area of partial shadow, where the light source is only partially blocked. Some of the light can still sneak around the edges to get there. And this is the aha moment. That penumbra is why your shadow on the ground has fuzzy edges instead of being a perfectly sharp outline. And this diagram just illustrates it perfectly. You can see the straight lines of light coming from the source. The object blocks the rays that would hit the center of the screen. That's what creates the umbra. But notice how some light rays from the top and bottom of the source can still get past the object and hit the screen? That's what creates the fuzzy penumbra on the outside. Okay, now let's take this whole idea of umbra and penumbra and scale it way, way up. We're going to leave the sidewalk behind and head out into space. So let's think about our 3 ingredients again. The sun is our light source, the screen can be the Earth, or it can be the moon. So what happens when the opaque object blocking the light is an entire planet? You get an eclipse. That's all it is. An eclipse is just a giant shadow being cast in space. When the Earth's shadow covers the moon, that's a lunar eclipse. And when the moon's much smaller shadow falls on the Earth, we call that a solar eclipse. It's the exact same principle as your own shadow, just on a totally mind-blowing scale. So the whole thing really just boils down to alignment. Who's in the middle? For a solar eclipse, the moon gets right between the sun and the Earth, casting its little shadow onto our world. For a lunar eclipse, the Earth moves right between the sun and the moon, and our planet's huge shadow just swallows the full moon whole. So we've seen what happens when light gets blocked, but that's not its only trick. What happens when, instead of being blocked, it hits a really shiny surface, like a mirror? It bounces. We call this reflection, and it follows a super simple and predictable rule. The angle that a light ray comes in and hits the mirror, we call that the angle of incidence, is always, always exactly equal to the angle that it bounces off, the angle of reflection. It's simple, it's elegant, and it's the reason you can see your own face in the morning. All right, let's wrap this up with the big takeaways. Number 1, The golden rule is that light travels in straight lines. Number 2, shadows happen when something opaque gets in the way of those lines. 3, a shadow has a dark center, the umbra, and a fuzzy edge, the penumbra. And finally, number 4, eclipses are just what happens when planets and moons cast shadows on each other.
And I'll leave you with one final little puzzle to chew on. We've established that light only travels in straight lines. So how in the world can you use a simple, flat mirror to see what's around a corner? The answer connects everything we've just talked about. Think about it.